Morning, children. It is I, Mr. E, and here we are today. Last day in the unit before we review for the test. This is all about how to solve systems to equations, or not equations, how to solve two systems. Let me start over. How to solve a system of inequalities. So two inequalities. There's only one way to do that. So let's get started. There's only one way to do that, and that is to graph them. The only way to solve systems of inequalities is by graphing, which I'm sure you're happy to hear that. So you don't have to do any math. You can just color things. So in order to solve these systems by graphing, you must shade and find the region that satisfies both inequalities. Right. So let's do this. We'll graph and shade. Graph and shade. And I'll show you what I mean. So let's graph each system of inequalities. Let's graph this first. X is greater than 5. And remember, if you just have an X and a number, that's right, this is Vux. So this is going to be a vertical line. So go to this axis, the x-axis, at this number. 5 there. Sorry, microphone. There we go. Okay, so go to that axis, x at 5. So 2, 3, 4, 5 right here. So this is where our line is, right here. Get nice and, oh, you know what I can do? I can do this. There we go. So 1, 2, 3, 4, 5 right here. There we go. So there's our line. There's our first line. Oh, you know what? Thank you. Yeah, I know you saw this before I did. This is going to be a dashed line. So let me wake up this morning. 1, 2, 3, 4, 5. This is going to be a dashed line at 5. So here we go. All right, now we're cooking with gas. Okay, there's that one. And which way are we going to shade? We're going to shade in that direction. Yeah, that's it. For a vertical line, shade in the direction that the inequality is pointing. So we're going to shade to the right. So I'm going to get a highlighter and shade my purple. I'm going to use this light purple and shade it to the right over here. So this is my solution set. Everything to the right of the dashed line. That doesn't include the dashed line. Okay, so now I'm going to get a different color. It's going to look good against this. How about green? It'll stand out. And then we're going to graph this one. So this is Y. So I'm going to go to the Y-axis, this axis, at this number. So 1, 2, 3, 4. And this is a solid line. It's got a solid line under the inequality. So it's a solid line at 4. 1, 2, 3, 4. So right here. There's my other line. There's my horizontal line. Yes, this is Y, so that's a hoy, horizontal line. Okay, or Y and just a single number. So, then I'm going to shade, well, this, I can make a down with this. Remember that? If you can make, not clown, but it's always hard to demonstrate that. If you can make the word, or the letter D with your inequality symbol, just like that, for down, then you're going to shade down. So we're going to shade down, and I'm going to get my highlighter back and use this green, and then you'll see the solution set. I should have used a better color. The solution set is going to be just like in the system of two linear equations where you have two lines and the point where they intersect is your solution. Now you have a bunch of solutions and they're all in this area here, which I will make darker. That area there, and I'm just gonna, circle it too because I picked some weird colors. this orange. This section here, where both colors are shaded. I know you understand. I'm just being overly specific. So that section there, where both shaded regions intersect, that is the solution set. So let's answer these questions. Is 8 minus 4 a solution of the system? Well, let's see. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4. That's this point right here. Different color. I'll do black. It's this point right here. That is in the solution set. Yes, it's in that double shaded area. Actually, yeah. Is 5, 0 a solution of the system? Let's see. 1, 2, 3, 4, 5. Well, that is on the dashed line. So no, it's not. That's on the dashed line, even though it's in this region. It's not fully in this region. So we're not going to count that. So that's a no. How about 10, 4? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, all the way out here to the edge. 1, 2, 3, 4. Ah, that's on this solid line. So yes, that is in the solution set. Okay, let's do one more. Here's one that's a little more challenging to graph. And I'm going to use yellow and blue because those two stand out very nice. So here's a yellow equation. We're going to plot the b value here, 1, 2, 3. That's the y-intercept. They're going to use this slope to find some more points. So up 2 and over 1, up 2 and over 1, up 2 and over 1. We can go down 2 and backwards 1. Down 2 and backwards 1. There we go. And then we can draw, oh, yes, solid line. We're using a solid line. There we go. Good catch. Solid line. Okay, there's one, and we're going to shade down because I can make a D out of that. D-O-W-N. So let's shade down. Let's get our highlighter and shade down below the line. So underneath the line. There we go. Try to get this in one swoop here so it's all the same color. I would have to pick a high light color, but that's okay. Be able to see the shaded region even better. All right. Fun with coloring. Okay, now let's pick a different color. Back to my pen. Let's use blue. Blue. Okay, we're going to plot this one now. So here's the b value. It's at 1, which is right there. And then the slope is a negative 1. There's a 1 in front of that x, an understood 1, the invisible 1. So down 1 and over 1, down 1. Negative slope. And this is going to be a dashed line. So you know what? I think I'm just going to leave it as dots. Maybe not. I'll connect the dots. Maybe another pair. There we go. There. There's our dashed line, and we are going to shade again. Looks like we're going to shade down. So let's shade down underneath the line. Let's get our highlighter. We're going to get this blue color, and we're going to shade underneath. And looky here. That should have turned green. I guess it's kind of green. I chose those two colors because yellow and blue make green, but that's not really showing up very well, is it? Oh well. There we go. Make sure we don't miss any holes there. That's okay. So it's this region here. I'll just highlight it again so it's a little darker. This region here is a solution set where both of the, you know what I can do? I'll just color it green. Since that's what it's supposed to look like. Yellow and blue make green, right? I'll just yellow with blue on top. Okay. There we go. Oh, now it's looking green. Okay, well, you get the idea. Here, I'm just having fun coloring now. Okay, so let's answer these questions. Is 0, 0 a solution to the system? 0, 0 is right there, so yes, it is in the green region. It's in the double shaded. How about minus 2, minus 1? Minus 2, minus 1. Right there, that's on the solid line, so yes, that's still in the region. How about 2, 7? 1, 2, 1, 2, 3, 4, 5, 6, 7. That's up here. Nope, that's not in the green region. All right, let's go on to the last page and see what we got here. Just a couple more. Well, do we need to do another one? No, I'm going to let you guys do this one. So you can graph. Oh, you know what? Here, let me just get you started. Let me get you started because these are in standard form. So standard form, there's two ways to do this. One, you can find the intercepts. Here, I'll write it over here. One, find X and Y intercepts. Or 2, convert 2y equals mx plus b. So to find the intercepts, if you want to find the y-intercept, you set x equal to 0, which means that it just goes away. Then you solve the rest of this. So 2y, and you can just use equals if you want, because we're just finding the intercept. 2y equals 6, so divide by 2, y equals 3. So the b value for this one is 3. Okay, there's the one intercept. And then the x-intercept, you set y equal to 0. So that just makes that go away. So x equals 6. So there's the x-intercept. 1, 2, 3, 4, 5, 6. So there's your 2 intercepts. And now you can either draw the line there. We're going to use a dashed line because there's no solid line underneath that. So erase. We're going to use a dashed line. So you can't count the slope. We go 3 down and 1, 2, 3, 4, 5, 6 over. So 3 over 6. That reduces to 1/2. So we can go down 1 and over 2, down 1 and over 2, down 1. There we are. So there we found the slope. We plotted some more points. We're using a dashed line. So I can do this. There's one line. No, I said I'd get you started, but I did it for you. So the other way, and I'll do this one. So that one we found the intercepts. This one will just convert to slope-intercept form. So we'll subtract 3x from both sides. That gives us minus y is less than 4 minus 3x. Look what's going to happen though. We're going to need to divide by negative 1. Divide by negative 1, divide by negative 1. That changes the signs, but remember, when dividing an inequality by a negative number, you must flip the inequality sign. Remember that when dividing or multiplying. When dividing or multiplying an inequality by a negative number, you have to flip that inequality sign. So this, put it up here. This is going to become y is greater than a positive 3x minus 4. So I divided this. Let's go back down to right here. That cancels, so that becomes a positive y. This becomes a negative 4, so I'm going to put it at the back here. And then this piece right here, minus 3x divided by minus 1. That's a negative divided by a negative, so that becomes a positive 3x, and I put that in front there. So now we have it in our slope-intercept form. So there's that. You have the b value. You have the slope. You can plot that and find the solution set. So there you go. Have fun. I will see you next time.